Woohoo, we are live. This is Math 40, Elementary Algebra, section 5.4. We're going to be talking about polynomials. And polynomials are actually something we've been working with already. We just didn't call them polynomials yet. Basically, we're looking at expressions which are built out of a combination of multiplication, addition, subtraction, constants, and variables. And you'll notice there's no division. We're not going to be dividing by x. So sadly enough, our vampire friends, blah, blah, will be leaving us until we get to them later, that much later in another chapter. So we've got a bunch of terminology because, you know, we got a brand new thing we're going to look at. Of course, we're going to come up with names for it. So the first one, monomial, comes from the word that means one. These are polynomials with a single term. So first thing you want to do is look at all these things that I claim are monomials and make sure you agree with me that the monomial has a single term. There's just one piece. This will be easier to see as we go on down. Spoilers, we're going to binomials next. You'll notice they have two terms, two pieces here. So monomials are a single piece. And every polynomial has a degree. And rather than giving you a very complicated description of what a degree is, I'm just going to tell you what the degrees are, and then you're going to catch on and your brain's going to come up with the rule. So if the monomial is x, the degree is 1. If the monomial is x squared, the degree is 2. Now, hopefully you're already starting to think about what you think, having a hypothesis. I wonder what the rule is. If the monomial is 3x squared, the degree is also 2. Pardon me. Hopefully that is confirming your ideas. Now, this I'm throwing in here, not because we're going to work with it, but because no one ever explains this, and I thought I would tell you now, and then you could tuck it away in your brain, and then later on when you're like, wait, what's going on? You're going to be like, oh, that's right. We talked about this. The degree of 3xy is also 2. The degree of the opposite of x cubed is 3. The degree of 14xy to the 4th is actually 5. And the degree of 6, not just the number 6, is 0. So, what do you think? Did this follow what you thought it was going to be? Do you have a suggestion about or a guess at what degree is measuring? Let's do a Dora style. What do you think degree measures? You're right. I hope you're right. Hopefully what you said is basically it's counting up the number of variables, and that is exactly it. If you've got a single x, the degree is 1. If you've got x squared, there are 2 x's. If you have something mixed, x and y, we actually count them together. So it's the degree is 2, although there's some tricky bits to this. Once we start bringing the variables into to play together, you will be in at least your 3rd semester of algebra, if not higher. And we will already have been talking about what there's some technicalities here, but not that we need to worry about it. And then why would the degree of just the number 6 be 0? You're right, because there's no x. Okay, let's move on. Binomials. So binomials are polynomials that have 2 terms. And there's something called a leading term. And I'm not sure why I put these this order, but I'm going to go ahead and say in x plus 1, the leading term is x. Okay, so you might have some theories about what that means, which tells us the degree of the binomial is 1. In 3x squared plus x, the leading term is 3x squared, so the degree is 2. And in the binomial 3x minus 14x cubed, the leading term is actually minus 14x cubed, which might be not what you were going to guess, and the degree is 3. So what is going on with the leading term and the degree? Well, the leading term is in a binomial. There are 2 terms. So it's whichever term has the highest degree. And then interestingly enough, the degree of the whole thing is just the biggest degree. So for example, we don't add 1 plus 3 to get a degree of 4 here. We say this has a degree of 1, this has a degree of 3, we'll go with the 3. So you go with the biggest degree. And the leading term is the term, the piece of the polynomial that has the greatest degree. Woohoo, woohoo. Okay, we did monomials, we did binomials. You know what's coming next. You got it. Trinomials. I hope you'll try to do these problems. Okay, so in a trinomial, we've got 3 terms. Woohoo. So in this first one, what's the leading term? Doesn't necessarily have to be the one that comes first. It's the one that's basically the biggest. And the biggest is measured by exponents. You're right. It's x cubed, which means this is a 3rd degree polynomial. Okay, in this trinomial, what is the leading term? You're right. Minus 16x to the 4th. Because again, it's the term of 4th, not 4th. Hello, 14th. Oh my goodness, this is a big polynomial. Look at that. It's the term that has the largest degree, and then the degree is that degree. Okay, one more thing to talk about. Descending order. So I'm going to say this polynomial, which has 1, 2, 3, 4. So this polynomial has 4 terms. And I claim that if you read through it, and again, remember we read left to right, it is listed in descending order. So what does that mean? Because 4, then 3, then 6, these numbers are not in descending order necessarily. What's in descending order? You got it. Get out my handy dandy highlighter. The way that they're descending is by power. So the largest exponent or the largest degree comes first, then the next, and on down the line. Generally speaking, you want to aim for descending order. In Math 40, I am honestly really happy when you get to the end of a problem, so I'm not going to take off any points if you don't put them in descending order, but I'm going to encourage you to practice it now, because as you go further up through algebra, it's going to become a thing that people are going to expect that you just naturally put things in descending order. So biggest power first, smallest, usually the constant comes last. Woohoo, we did it. Nicely done. Next up, we will add and subtract. It's going to be super fun.